This question says the temperature outside at 6 a.m. is 4 degrees Celsius. The temperature rises by 1.5 degrees Celsius every hour. This is very important. It's rising every hour. And like we just talked about, if you look at the table of values, they rose by 1 hour in the first row, and then what happened? What did they do all of a sudden? It increased by 3 hours. So we need to figure out, we know it rises by 1.5 degrees Celsius every single hour. If it's rising by the same amount every hour, what does that tell you about this relationship? If it's rising by a constant amount, what does that tell you about the relationship?
It's linear.
It's going to be linear. You automatically know from this that this relationship has to be linear. So when you go to graph it, if you graph something that was not linear, then you know you made a mistake somewhere. So they're looking for two things in this question. Are your values in your table correct? And is your graph linear? That's it. So let's fill in the table. Okay, what is one strategy you use to fill this in? Yep. So for the first one, we know that we just have to add 1.5 because every hour it's increasing by 1.5. So what's 4 plus 1.5? Now, it's increasing by 1.5 every hour. So we could do two things here. We can add it all. You can multiply by 3, yes. But I decided that I wanted to make a little table on the side, which is fine, because I wanted to visually see for every hour, and then I can just fill in the blanks. We have to go up to 6, right? So it starts at 4 degrees, then it goes to 5.5, and then for every single hour, because I'm increasing by 1 hour, we're going to add 1.5. So can you tell me what you got for the table? Good. And then for 3 hours, somebody else? 8.5. 10 hours, yep. I mean, for 4 hours? 10. For 5 hours? 11.5. And for 6 hours? Okay, so we added 1.5 plus 1.5 plus 1.5 plus 1.5. But the question is asking you to complete the table of values. You need to make sure that we fill in this information into this table, because that's what they're looking at in this question. Okay, so 4 hours was how many degrees? 10 degrees, and for 6 hours it was 13 degrees. That's it. Pretty straightforward for the table. Now, what's the second part of this question? Graph it. Okay? I'm not going to spend too much time on the graph, but what are some things that they might be looking for when they're marking your work for a graph? What is one thing that you have to do first? What's missing here? Yep. Yeah, the labeling's done already for you. These are our X values, the independent, and these are our Y values, the dependent. So that's already done, actually. Most of this graph is done for you. What's next? Yeah, there's a title. We need a scale, okay? So the highest value for temperature that we need to plot is 13 degrees. So you just need to pick a scale that starts at 0 and goes up to the highest value is 13. What would be a good number to count by then for this graph? So if you want to do 2, we can skip 2 squares, 2, 4, 6, 8, 10, 12, 14, and then we know that every single square represents 1, right? 1, 2, 3, 4, 5. You don't have to write in every single number, but now we just need to plot it. Okay, does anyone need help with graphing? Okay, so we know the first point is 0, 4. So 0, 4 would be here. It's on the y-axis. Actually, here's a good review question. Is this a direct or partial variation? Look at where the graph starts. Raise your hand if you think it's direct. Partial. How do you know? Because it does not start at the origin. It starts at 0, 4. So it has an initial value. The initial value is 0, 4. This is the initial value. Okay? Okay, so I just plotted the 4 points from here. Look here, I just plotted the 4 points from the table. I could plot all of these points, but all we need to do is just connect the points and we can see that it is linear. Okay, so as long as you have 4 points plotted on there, you would get full marks for this.